Okay. Okay. So what is the definition of Zn? Take x belongs to G such that x inverse G inverse belongs to Zn minus 1. Okay, so Zn minus 1 is the what? N minus 1 center of group G. Okay, the group G is said to be nilpotent if Zm of G is equal to G for some M. Okay, so this is the smallest M is known as class of nilpotency group. Okay, we will discuss it in the previous lecture. Okay, so every abelian group is nilpotent. Okay, why? Because G is equal to Z of G. If G is abelian, then G is equal to Z of G. And take singleton E is equal to Z naught of G and G is equal to Z1 of G. So Z naught of G is normal subgroup of Z1 of Z1G. So that here there exists a positive number M is equal to 1 such that Zm of G is equal to G. Hence, this every abelian group is nilpotent group. And the class of nilpotency of any abelian group is always 1. Okay, and one more result is there, is taken directly from the textbook. What is the result? Zn of G upon Zn minus 1 of G is contained in Z of G upon Zn minus 1 of G. Okay, so again we discussed the theorem. Okay, मागच्या लेक्चरला तुम्हाला कंटाळा आला असेल म्हणून समजलं नाही पुन्हा मी. So here I repeat again. Okay, what is the theorem? The subgroup of nilpotent group is nilpotent. Okay, subgroup of nilpotent group is nilpotent. So look at the proof. If G is the nilpotent group, then there is an ascending central series and a positive integer such that singleton E is equal to Z naught of G, which is contained in Z1 of G, which is contained in Z2 of G, up to so on, which is contained in Zn of G is equal to G. So this is the ascending central series for group G. Give it as equation number 1. Take H is the any subgroup of G and we assuming singleton E is equal to Z naught of G, which is contained in Z1 up to so on. Okay, be the ascending central series for H. We have to prove that the subgroup of nilpotent group is nilpotent. That is, we have to prove that Zn of H is equal to H. Okay, we have to prove that there exists a positive integer n such that Zn of H is equal to H. Or has Zn of H कसा define करायचा है? Look at here. From 1 we have taken Z naught of H, Z naught of G intersection with H and give it as a singleton E. Okay, the singleton E is equal to Z naught of G intersection H, which is contained in Z1 of G intersection H, which is contained in up to Zn of G intersection singleton H is equal to H. Okay, why? Because H is the subgroup of G and Zn of G is nothing but G. So G intersection H is equal to H. Okay. So we have to prove this is the series for H, ascending central series. Okay. Now we shall show that Zi of G intersection H is contained in Zi of H. Okay. We have to show that Zi of G intersection H is contained in Zi of H. म्हणजेच वरच्या ज्या सेंट्रल अशा सिरीज मध्ये झेड नॉट ऑफ जे इंटरसेक्शन एच इज नथिंग बट झेड नॉट ऑफ एच हे प्रूव्ह करायचं आपल्याला. ओके, सिमिलरली z1 of g intersection h is contained in z1 of h. Okay, we have to prove this one. Now from the in the first step clearly we have z naught of g intersection h is equal to z naught of h. Why? Because z naught of h is nothing but singleton e. Okay, so here z naught of g, here we have z naught of g intersection h is nothing but z naught of h g is a singleton e. So singleton e intersection h is nothing but singleton e. Okay, so clearly we have z naught of g intersection h is equal to z naught of h, which is singleton e. Okay, now again taking x1 from z1 of G intersection H, and we have to prove that this element goes in z1 of H, x belongs to z1 of H. Okay, why? Because we have to prove this one, zi of G intersection H is contained in zi of H. Taking I is equal to 1, what we have then, z1 of G intersection H is contained in z1 of H. Okay, we have to prove this one. That's why we have taken the any element from this group z1 of G intersection H. It implies that, what it implies, it the element is in the intersection, so it implies x1 is also is belongs to z1 of G, and also x belongs to H, sorry, x belongs to z1 of G and x is also belongs to H. But by the definition of z1 of G, okay, x belongs to z1 of G, what it means, x y x inverse y inverse belongs to z naught of G, which is equal to singleton E, and x belongs to H for all y belongs to G. Why? Because the definition of z1 of G says that x y x inverse y inverse belongs to z naught of G by the definition of this one. Okay, take n is equal to 1 here. So what we have, x belongs to G, x inverse and y inverse belongs to z naught of G. Okay, using that definition here. Okay, so for all y belongs to G is here. Okay, but H is the subgroup of G, na? Hence, here in the third row, in this step, x inverse y inverse belongs to z naught of H. Why? Because singleton E is nothing but also z naught of H, which is equal to also singleton E. And x belongs to H, the all other term as it is. Okay, which implies that x inverse y inverse belongs to z naught of H, which is equal to singleton E. X belongs to H as it is for all y belongs to H. G मधल्या सगळ्या एलिमेंटला ट्रू असेल तर H मधल्या पण सगळ्या एलिमेंटला ट्रू असायला पाहिजे, बिकॉज H इज द सबग्रुप ऑफ G. But this is the definition of x belongs to Z1. Okay, this is the definition of x belongs to Z1, which implies that we taken the element x from Z1 of G intersection H, then the x is going to Z1 of H. It implies that Z1 of G is contained in Z1 of G intersection H is a subset of Z1 of H. Okay, any doubt up to here? Any doubt up to here?
No, sir.
So first we prove for Z naught. Now we are proved for Z1. Now assuming for Z is equal to sorry M, for M is equal to true, N is equal to M is equal to true, then so what we have, Zm of G intersection H intersection Zm of H for some M. So assuming this statement correct, we have to prove that for M plus 1 is also the statement is correct. Okay. Similarly, we have consider X is the any element from Zm plus 1 of G intersection H. It implies that x belongs to H and x belongs to Zm plus 1 G. Okay. So here x belongs to H as it is. And what is the Zm plus 1 of G? The definition of Zm plus 1 of G is nothing but x inverse y inverse belongs to Zm plus 1 minus 1 belongs to G. But plus 1 minus 1 get cancelled. So only Zm of G is there for all y belongs to G. This is the definition of Zm of G. Sorry, Zm plus 1 of G. If x is the any element from Zm plus 1 of G, then using the definition, we have this. Okay. So x belongs to H and x inverse y inverse belongs to Zm of G for all y belongs to H. Since here all y belongs to G, it also true for all y belongs to H because H is the subgroup of G again. Okay. Similarly, It implies that X belongs to H and X inverse Y inverse belongs to Zm of G intersection H. Okay, intersection H. Why we take an intersection? In the previous step, only Zm of G is there, but here Zm of G intersection H is taken. Why? Because look at here, X belongs to H. It implies that X inverse also belongs to H. Y belongs to H. It implies that Y inverse also belongs to H. Okay, so product of all this term going to also H. X, Y, X inverse, Y inverse is the element from also H by closure property of subgroup or group. Okay, that's why we have taken here X, Y, X inverse, Y inverse belongs to Zm of G intersection H, or all Y belongs to H. But look at here. X belongs to H and X inverse Y inverse belongs to Zm of G intersection H, which is contained in Zm of H. Why? Because in the assumption part we have taken Zm of G intersection H is contained in Zm of G. हे assume केलेलं आहे आपण. That's why we have taken X inverse also belongs to Zm of H, or all Y belongs to H. But this is the definition of what? X belongs to Zm plus 1 H. Okay, but this is the definition of X belongs to Zm plus 1 H. Hence, we get, or taking X is the element from Zm plus 1 of G intersection H. Now here we got the X belongs to Zm plus 1 of H. It implies that Zm plus 1 of G intersection H is contained in Zm plus 1 H. Okay, any doubt up to here?
No, sir.
Okay, therefore we taken for all K the statement is true. म्हणजे मॅथमॅटिकल इंडक्शन सारखं हे प्रूव्ह केलेलं आहे. आधी झिरोला प्रूव्ह केलं, मग वनला प्रूव्ह केलं, मग ॲझम्पशन काय केलं, एम साठी पण ट्रू असेल आणि एमचा वापर करून काय केलं आपण एम प्लस वनला पण ट्रू करून दाखवलंय. ओके, therefore we have zk of G intersection H is contained in zk of H for all k. Okay, for any k this statement is always true. Okay, but look at here, what is the Zn of G intersection H? What is the value of this one? Zn of G intersection H is nothing but, look at here, Zn of G intersection H is equal to H now. Hence, we write here H is equal to Zn of G intersection H. But in the previous step, we prove that this is contained in Zn of H by previous step. Okay, Zn of H. But Zn of H is contained in what? H. Why? Zn म्हणजे काय? हा यंत काय असेंडिंग ग्रुप आहे ना. यंत कुठला ग्रुप आहे हा? Zn of H always contained in H. ओके, असेंडिंग सेंट्रल सिरीज मध्ये Z1, Z2, Z3 यात सगळ्यात मोठा कोण असतो? H असतो. हेन्स Zn of H is contained in H. लेफ्ट साइडला पण H आहे, राईट साइडला पण H आहे, म्हणजे हा काय येणार? Zn of H is nothing but H. Okay, here in the left side also H and also at the right side is H is there, subgroup. So Zn of H is nothing but whole H. So here we get the smallest integer n such that Zn of H is equal to H. It implies that H is nilpotent group by the definition of nilpotent group. Okay, H is nilpotent subgroup of G. Here we proved that if G is the nilpotent group, then the any subgroup of the nilpotent group is nilpotent group. Okay, up to here any doubt?
No, sir.
Okay, can we move in the next point towards next point?
Yes, sir.
Okay, and the next theorem is homeomorphic image. Homomorphic image of nilpotent group is nilpotent. The homeomorphic and homomorphic, these are the two different things. Okay, ते माझ्या प्रत्येक वेळेस होमिओमॉर्फिकच येतं तोंडात. Sorry, homomorphic image of nilpotent group is nilpotent. Okay, for this let us see proof. Let G be a nilpotent group with ascending central series singleton E is equal to Z naught, which is contained in Z1 of G, which is contained in Z2 of G, up to so on, is contained in Zn of G, which is equal to G. Why? Because G is the nilpotent group. Okay, give it as equation number 1. Now let define a function phi from G to G dash with the homomorphic function. Okay, असा फंक्शन घेतानाच असा फंक्शन घेतलंय की तो होमोमॉर्फिक असायला पाहिजे. Okay, so without loss of generality, we may take phi is on to homomorphism. म्हणजे घेतानाच ह्याचा अर्थ काय, जर घेतानाच असा फंक्शन घ्यायचा की तो ऑन टू होमोमॉर्फिझम असायला पाहिजे. ओके, thus we now required to show that G dash is the nilpotent group. Okay, so here G is nilpotent. Okay, and we have to prove taking phi is on to homomorphism. We have to prove that G dash is the nilpotent group. Why? Because we have to prove the homomorphic image of nilpotent group is nilpotent. So we have to prove that this G dash is nilpotent group. Okay. So we shall prove that this by showing that what phi of zk of G, the zk of G is the kth center of G. Okay. Kth center of G taking the phi image. Okay. It's contained in zk of phi of G. Okay, which is equal to zk as it is, and phi of G is nothing but G dash, whole G dash. Okay, so zk of G dash. If we prove this one, so automatically we get G dash is the what, nilpotent group. Okay, zk of G dash. Okay, the G dash be the nilpotent group. So this also we can prove by mathematical induction on K. Okay, we shall prove this by induction method on K. Okay, take K is equal to 1. So what we get? If X belongs to phi of Z1 of G, Z1 of G is nothing but first center, first center of group G, taking the phi image of that group. Okay, which implies that X is equal to phi of Y, where Y belongs to Z1 of G. कळतंय हे definition कसं आलं?
Yes, sir.
Okay, if you take on any element X belongs to phi of Z1 of G, it means that तो phi च्या range मध्ये आहे. ओके, म्हणजे X is equal to phi of Y येणार, where Y belongs to कुठून येणार? Z1 of G. कळतंय हे फर्स्ट लाईन, फर्स्ट ॲरो कळतंय रो? Any difficulty? Okay, it implies that X is equal to phi of Y and Y belongs to Z1 of G. It means that Y is commute with all the elements of G. Taking Z1 of G is equal to Z. First center is Z1 of G is nothing but taking Z1 of G is equal to Z of G. ओके, म्हणजे तो काय होणार, Y जर हा Z1 of G मधनं घेतला आपण, तर तो काय होणार, Y हा कोणाला कॉम्प्युट होणार? Z ला कॉम्प्युट होणार. Z कुठून आहे? G मध्ये. म्हणजे हा Y G च्या सगळ्या एलिमेंटला कॉम्प्युट झाला तरच तो Y ह्या Z1 G मध्ये जाणार ना. सो बाय द डेफिनेशन ऑफ सेंटर, this Y is commute with all the elements, all other elements from G. Okay, it implies that X is equal to phi of Y and YZ is equal to ZY for all Z belongs to G. Okay, this is the small z आहे बरं का, हे स्मॉल z आहे. दिस Z1 आणि हे Z वेगळे आहेत. हा Z एलिमेंट आहे आणि हा Z1 G काय सेंटर आहे, फर्स्ट सेंटर. फर्स्ट सेंटर इज नथिंग बट here we taken as first center Z1 of G is equal to Z of G. Okay, so here it implies X is equal to phi of Y and taking the phi image on both sides, phi of YZ and phi of ZY is for all Z belongs to G, but phi is homomorphism, onto homomorphism. Implies that X is equal to phi of Y and phi of YZ is nothing but phi of Y into phi of Z, which is equal to phi of Z into phi of Y for all Z belongs to G. Okay. Hence, we get, but x is equal to what? Phi of y. So putting the value of phi of y here, what we have? X into phi of z, which is equal to phi of z into x for all small z belongs to G. Okay. So assuming phi of z is equal to z dash. Okay. Why? The image of z, हा इमेज कुठे जाणार? फाय ऑफ झेड कुठे असणार? जी डॅश मध्ये असणार. ओके. इमेज ऑफ दिस एलिमेंट झेड हा जी मधून आहे, मग फाय ऑफ झेड कुठे येणार? जी डॅश मध्ये येणार. ओके. Hence, assuming phi of z is equal to z dash, so x z dash is equal to z dash x for all z dash belongs to g dash. Since phi is onto, okay, phi is onto means what? The whole range set is equal to codomain. Codomain मध्ये कोणताही मेंबर, सगळ्या मेंबरला काय आहे? प्री इमेज आहे डोमेन मध्ये. ओके. सो phi is onto here. That's why for all z dash belongs to g dash we take up. Okay. But what is the definition of this one? तुमच्या जी डॅश मधल्या सगळ्या एलिमेंटला कॉम्प्युट करतोय कोण? एक्स कॉम्प्युट करतोय, विच मीन्स दॅट एक्स बिलॉंग्स टू z1 ऑफ जी डॅश. कळतंय? एक्स हा जी डॅश मधल्या प्रत्येक एलिमेंटला कॉम्प्युट करतोय. याचा अर्थ काय? तो त्याच्या सेंटर मध्ये असला पाहिजे. ओके. बट इथं z1 ऑफ जी डॅश इज नथिंग बट z ऑफ जी डॅश, विच मीन्स दॅट we have taken x belongs to phi of z1 of g, and here we get x belongs to z1 of g dash, which means that this is the subset of z1 g dash. Thus we get phi of z1 of g, which is subset of z1 of g dash. Okay. So as an induction hypothesis, suppose this statement is true for k. Okay. Then what we have? Phi of zk of g is contained in zk of phi of g. Okay, but phi of g is nothing but g dash. Okay. Why? Because phi is onto homomorphism, which is equal to zk of g dash. Assuming this statement, we have to prove for this statement is also correct for k plus 1. Okay, induction मध्ये असंच प्रूव्ह करतो ना आपण. आहे का लक्ष?
हो सर.
हो सर.
Assuming this statement is correct for k, we are going to prove this statement is also correct for z n is equal to k plus 1. Okay. So taking any element x from phi of zk plus 1 of g, which implies that x is equal to phi y for some y belongs to zk plus 1 of g. Okay. Implies that x belongs to phi of y, where what is the definition of this? Y belongs to zk plus 1 of g, which means that definition use करा पुन्हा त्याची zn of g ची. y inverse belongs to zk of g. अच्छा, खालच्या ग्रुप ह्याला येणार तो सेंटरला. a प्लस 1 मध्ये जर एलिमेंट असेल तर तो झेडकेच्या प्रत्येक एलिमेंटला कॉम्प्युट हे करत असतो. अशी असणार डेफिनेशन. y इनवर्स दिस होल एलिमेंट्स बिलॉंग्स टू zk of g. For all z belongs to g, small z. Okay. Which implies that x is equal to phi of y and taking the phi image on both sides. Okay. So what we have? Phi of y inverse belongs to phi of zk of g. Phi of zk of g is nothing but which is contained in what? By in the induction hypothesis, what we assume? Phi of zk of g is contained in zk of phi of g at here. Okay. By assumption, zk of g dash. Okay. Implies that phi of y into phi of z into phi of y inverse into phi of z inverse, okay, belongs to zk of g dash, and phi of y is equal to x. Okay. Any doubt up to here? By assumption वापरलं हे. Okay, so what is the value of phi of y? Is x. Phi of z कुठे येणार? g dash मध्ये येणार. g dash म्हणजे त्याचा एलिमेंट कसा असणार? z dash. Suppose this is z dash. So x inverse, phi of y inverse is nothing but x inverse. And phi of z bracket whole inverse is equal to z dash inverse. Belongs to zk of g dash. For all z dash belongs to g dash. But this is the definition of x belongs to zk plus 1 g dash. Okay. This is the definition of what? X belongs to zk plus 1 g dash. Hence, here we taken any element from phi of zk plus 1 of g. Here we got x belongs to zk plus 1 g dash. Okay, so phi of zk plus 1 g is the subset of zk plus 1 g dash. Okay, any doubt up to here? बघा चेक करा पुन्हा. To here any doubt? कोणती स्टेप समजली नसेल तर विचार. ओके, जायचं पुढे. So here we get phi of zk plus 1 g is the subset of zk plus 1 g dash. Okay, but whenever phi of zk of g is the subset of zk of g dash, hence by the induction method we prove that for any k plus 1 is for any k this statement true. So taking phi of zm of g is contained in zm of g dash for any positive integer is true. Okay, so hence we get g dash is nothing but phi of g. Okay, g dash is nothing but phi of g because phi is onto homomorphism, which is equal to phi of zn of g. Okay, why? Because g is nilpotent. Nilpotent means take g, g is equal to zn of g. So instead of g, we can write zn of g. Okay, here. So phi of g is equal to phi of zn of g. But phi of zn of g is contained in zn of g dash by previous step. Okay, zn of g dash. But zn of g dash is always a subgroup. Okay, always the subset of g dash. Okay, so here we get at the left hand side g dash and also right hand side g dash. Then implies that zn of g dash is equal to g dash. Okay, zn of g dash. Look at here. We are assuming this one only. G dash is contained in zn of g dash, which is contained in g dash. समजा g हा h चा सबग्रुप आहे. Assume. Okay, so h is the subset of g, but g is the subset of also h. Then what we can say? What we can say that g
H is
must be
equal
equal
to G.
to h. Hence, here we taken zn of g dash is equal to g dash. Okay, so here we getting the integer n such that zn of g dash is equal of g dash is equal to g dash. Thus, here the g dash is the nilpotent group. Okay, any doubt? So we proved that the homomorphic image of nilpotent group is nilpotent. Okay, any doubt up to here? Can we move towards next point?
Yes, sir.
The next theorem is that any group of order p raised to n is nilpotent group. Okay, कधी कधी असंही विचारू शकतात पी ग्रुप एनी पी ग्रुप एखाद्या ग्रुपची ऑर्डर जर पी रेस टू एन असेल वेदर वेअर पी इज प्राईम त्या ग्रुपला आपण पी ग्रुप असंही म्हणू शकतो. फॉर एक्झाम्पल 2⁵ 8. ओके, एनी 8 ऑर्डरचा ग्रुप असेल त्याची ऑर्डर कशी असणार 2⁵ मध्ये आहे ना, मग त्याला पी ग्रुप ही असंही म्हणू शकतो. एनी ग्रुप ऑफ ऑर्डर पी रेस टू एन इज nilpotent or any p group is nilpotent. State and proof विचारू शकतो. Okay, so let's see the proof of this theorem. कालचं हे चेक केलं का हे कसं आलं? If P divides order of G, then center of G is not equal to singleton E. ओके, चेक केलं कोणी? जर एखाद्या ग्रुपची ऑर्डर पी रेस टू एन या फॉर्म मध्ये असेल तर त्याच्या सेंटर मध्ये एकापेक्षा जास्त एलिमेंट असतात. चेक केलं का? टेक्स्टबुक कोणी चेक केलं का? पाहिले का? लिहून घ्या. थेरम नंबर 4.10 पेज नंबर 113 भट्टाचार्य. ओके, त्याचं नाव आहे भट्टाचार्य. पेज नंबर 113 113 थेरम नंबर 4.10 टेक्स्टबुकचं नाव आहे भट्टाचार्य. या ह्याच्यामध्ये ह्याचं प्रूफ आहे. एनी पी ग्रुप ॲज अ नॉन ट्रिव्हियल सेंटर. नॉन ट्रिव्हियल याचा अर्थ काय? त्याच्या सेंटरमध्ये एकापेक्षा जास्त एलिमेंट असतात. झेड इज इक्वल टू सिंगलटन ई असेल तर तो ट्रिव्हियल सेंटर झाला. ओके, इफ झेड जी इज इक्वल टू सिंगलटन ई असेल तर तो काय झाला? ट्रिव्हियल सेंटर. बट हियर झेड जी इज नॉट इक्वल टू सिंगलटन ई, हेन्स दिस इज नॉन ट्रिव्हियल सेंटर. काल एक लिंक सेंड केली मी गुगल क्लासरूमला, पाहिलं का? युट्यूबची एक लिंक टाकली होती मी. कोण कोण पाहिलं? एनी पी ग्रुप हॅज अ ट्रिव्हियल नॉन ट्रिव्हियल सेंटर. पाहिली का नाही?
नो सर.
नो. मग बघा ती. ओके, एखाद्या ग्रुपची ऑर्डर जर पी असेल, सॉरी पी रेस टू एन या फॉर्म मध्ये असेल तर त्याच्या सेंटर मध्ये एकापेक्षा जास्त एलिमेंट येतात. कसं येतात ते क्लास इक्वेशन घेऊन दाखवलेलं आहे. क्लास इक्वेशन कुठे आहे? अजून पुढे आहे आपल्याला. Look at the theorem. Any group of order p raised to n is nilpotent group. ओके, एखादा तुम्हाला ग्रुप फायनाइट ग्रुप दिलेला आहे. तुम्ही जर nilpotent आहे हे ओळखायचं असेल तर काय चेक करणार? त्याची ऑर्डर चेक करा पटकन. p raised to n या फॉर्म मध्ये आहे का पहा. असेल तर डायरेक्ट त्याला nilpotent ग्रुप म्हणायचं. ओके, सेटच्या क्वेश्चन ह्याच्यामध्ये विचारतात, असेच क्वेश्चन विचारतात. थेरमचं स्टेटमेंट तुम्हाला माहिती आहे. Which of the following is nilpotent group if order of G is equal to dash dash. देतात 4 ऑप्शन. त्या 4 ऑप्शन मधून चेक करायचं कोणते पी रेस टू एन या फॉर्म मध्ये आहे. कळतंय? ओके, any group of order p raised to n is nilpotent group. Let G be a group with order of G is equal to p raised to n. Okay, we have to prove that the G is nilpotent group. Okay, if G is abelian, समजा एखादा फायनाइट ग्रुप दिलेला आहे तुम्हाला, ते दोन पॉसिबिलिटी असू शकतात. तर जी अबेलियन असेल किंवा नॉन अबेलियन असेल. ओके, सर जर जी हा अबेलियन असेल, इफ जी इज अबेलियन, so what is the center of that group?
Z of G.
Z of G is equal to whole G. Okay, if group is abelian, then center of G is equal to G. Okay, so we can write if group is abelian, then G is equal to Z of G. तर उलटे घेतले. If suppose G is equal to Z of G, then result is obviously true. Okay, why? That is the G is abelian. का मग काय येणार? जर G हा abelian असेल तर G is equal to Z of G येणार आणि Z नॉट काय येणार? सिंगलटन येणार. So singleton E is contained in Z of G here. Here we get for M is equal to 1. Okay, put Z of G ला Z1 of G म्हणा. Okay, so here we get M is equal to 1 such that Z1 of G is equal to G. Hence, there is nothing to prove. So obviously, the G is the nilpotent group. Okay. Okay. Yes or no? समजते का?
Yes, sir.
Okay. So if
Yes, sir. Yes, sir.
मग
Sir.
सांगा ना मग, which implies that z of g is not equal to singleton e. Why? Because by using class equation method ने प्रूव्ह केलं. ते लिंक पहा, युट्यूबला ह्याला टाकले, गुगल क्लास तुम्हाला, किंवा थेरम नंबर 4.10 पेज नंबर 113, टेक्स्टबुकचं नाव आहे भट्टाचार्य, अल्जेब्रा बाय भट्टाचार्य, त्याच्यामध्ये आहे. एखाद्या ग्रुपला जर पी डिवाइड करत असेल, एखाद्या प्री ग्रुप असेल, सॉरी, एखाद्या ग्रुपची ऑर्डर पी रेस टू एन असेल, तर त्याचा सेंटर हा नॉन ट्रिव्हियल असतो. नॉन ट्रिव्हियल म्हणजे त्याच्यामध्ये एकापेक्षा जास्त एलिमेंट असतात. ओके, सो हियर द झेड ऑफ जी इज नॉट इक्वल टू सिंगलटन ई. That is, the order of z of g is not equal to 1. Okay, so we know that z of g always the normal subgroup of what? G. Okay, hence we get order of z of g divide must be divide order of g. Is it correct?
Yes, sir.
एखाद्या सबग्रुपची ऑर्डर हा ग्रुपच्या ऑर्डरला काय करतो? डिवाइड करतो. ओके, बट ऑर्डर ऑफ जी काय येते? पी रेस टू n. Okay, so what we have then, the order of z of g must be equal to p raised to r, where r is less than n. म्हणजे या ऑर्डर, ह्या झेड ची ऑर्डर, झेड ऑफ जी ची ऑर्डर किती असायला पाहिजे? एक तर 1 असायला पाहिजे. 1 तर नाहीच, इकडे पॉसिबिलिटीज नाही. ओके, सो व्हॉट वी हॅव, पी असायला पाहिजे, पी स्क्वेअर पी क्यूब अप टू पी रेस टू आर, वेअर धिस आर इज लेस दॅन एन. ओके, आर इज इक्वल टू एन का असणार नाही? बिकॉज आर इज इक्वल टू एन काय?
Abelian होईल.
हा, अबेलियन होईल. व्हेरी गुड, बिकॉज हियर वी टेकन जी इज नॉन अबेलियन. Hence, the order of z of g is equal to p raised to r, where r is less than n. Up to here, any doubt?
No, sir.
Okay, now consider order of g upon zg, which is equal to order of g upon order of z of g, which is equal to p raised to n upon p raised to r, which is equal to p raised to n minus r. Okay, so what we have then, order of g upon zg is equal to p raised to n minus r. It implies that P divides again order of G upon ZG. Okay, is it correct? या P raised to n minus R ला P divide करतोय का?
Yes, sir.
Obviously. It implies that the center of that group Z of G upon ZG is not equal to ZG. Okay, again या ग्रुपचा सेंटर. ओके, कळतं का? एखाद्या ग्रुपला पी डिवाइड करतोय, पुन्हा इथे त्याचा सेंटर काय असणार? या ग्रुपचा सेंटर नॉन ट्रिव्हियल असणार, विच इज इक्वल टू झेड अपॉन, सॉरी, झेड जी. ओके, इथे लक्ष द्या नीट. इफ पी डिवाइड्स ऑर्डर ऑफ जी, ओके, या जी ची आयडेंटिटी काय? जी ची आयडेंटिटी काय? सिंगलटन ई. सो या ग्रुपच्या सेंटरमध्ये झेड ऑफ जी इज नॉट इक्वल टू सिंगलटन ई. Okay, similarly here, look at here. If P divides this one, order of G upon ZG. So what is the order identity of this factor group?
Singletony.
Factor group.
Z of G.
Z of G.
This is the identity. Hence, the center of this factor group is not equal to Z of G. कळते का? सिंगलटन ई ऐवजी ते काय आलं? Z of G आलं. तेच स्टेटमेंट यूज केलेलं आहे वरचा. इथे जो सिंगलटन ही होता, इथे जी च्या ऐवजी काय काय फॅक्टर ग्रुप घ्या, जी बाय झेड जी. ओके, सो सेंटर ऑफ जी अपॉन झेड जी इज नॉट इक्वल टू आयडेंटिटी ऑफ दॅट फॅक्टर ग्रुप. ओके, सो व्हॉट इज द फॅक्टर ग्रुप? आयडेंटिटी ऑफ फॅक्टर ग्रुप झेड ऑफ जी. ओके, कळतंय? कळते का? पुन्हा एक्सप्लेन करू? Can I repeat again?
No, sir.
फक्त या स्टेपमध्ये काय करायचं तुम्हाला, जीच्या ऐवजी फॅक्टर ग्रुप घ्यायचा आहे, जी अपॉन झेड जी. या जीचा आयडेंटिटी काय होता, सिंगलटन ई होता. तिथे फॅक्टर ग्रुपची आयडेंटिटी काय येणार, झेड जी येणार. जर जी अपॉन झेड जी घेतला तर त्या ग्रुपची फॅक्टर ग्रुपची आयडेंटिटी काय येणार, झेड जी. सो हियर वी गेट z of g upon zg is not equal to z of g. Hence, by the definition of z2 of g, we get z1 of g always contained in z2 of g, where z1 of g is equal to z of g. Okay, assume z1 of g is equal to z of g. Okay, so that is order of z1 of g is less than order of z2 of g. Okay, any doubt? याला झेड टू ऑफ जी म्हणा. ओके, ह्याला झेड टू ऑफ जी म्हणा. ओके, कळतं का? ह्याला झेड वन ऑफ जी म्हणा. हा सिंगलटन, हा जो आहे झेड ऑफ जी इज नॉट इक्वल टू सिंगलटन ई. ह्याला झेडला झेड वन म्हणा. आणि इकडे काय घ्यायचं, हा ह्याला ह्या ग्रुपच्या ऑर्डरला झेड टू. सो हियर वी नो दॅट झेड वन ऑफ जी इज कंटेंड इन झेड टू. सो कंटिन्यूइंग दिस वे, order of z1 of g is contained is less than order of z2 of g. Okay, up to so on we get p raised to n which is equal to g. Okay, कळतंय? या z1 ला, ह्या सिंगलटन ई ला काय म्हणा, z1 म्हणा. ओके, so continuing in this way we get order of z1 of g is less than order of z2 of g up to so on p raised to n which is equal to g. Singleton E is nothing but Z1. Okay. Okay. Hence, there exists a positive M such that, least positive M such that order of Zm of G is equal to P raised to N. Give it as equation number 1. But Zm of G is the always subset of subgroup of G, which means that Zm of G is nothing but G. Okay. Any doubt up to here? Hence, the G is nilpotent. So, any group of order P raised to N is the nilpotent group. Okay. बघा, चेक करा काही समजत नाही काही. Okay, any doubt up to here? Okay, Z1 of G always contained in Z2 of G. Okay, contained up to Zm. Up to so on काय येणार, Zm of G which is equal to G येणार. Okay, इथे ऑर्डर काय
सर
आहे,
तुमचा वॉइस ब्रेक
फायनाइट
होतोय.
आहे, P raised to N फॉर्म. Okay, here by the definition of Z2 of G, we get Z1 of G is always contained in Z2 of G. Okay, hence the order of Z1 of G is less than order of Z2 of G. Okay, hence there exists a positive M such that order of Zm of G is equal to P raised to N. But Zm of G is a subgroup of G. 2 from 1 and 2 we can say that Zm of G is equal to G. ओके, एखादा जी हा एच हा एखादा जी चा सबग्रुप आहे समजा, आणि एच ची ऑर्डर ह्या जी ची ऑर्डर एवढी आहे, मग तो काय होणार, एच इज इक्वल टू जी होणार ना. तेच यूज केलं इकडे. झेडएम ऑफ जी, याची ऑर्डर किती आहे, पी रेस टू एन. बट झेडएम ऑफ जी हा कोणाचा सबग्रुप आहे, जी चा सबग्रुप आहे. हेन्स दॅट झेडएम ऑफ जी इज नथिंग बट झेडएम ऑफ जी. ओके, ओके, एनी डाउट?
नो सर.
Okay, so this is the today's part. Okay, so in the next part, wait a minute for some time. One more theorem is there. Look at some. Wait a minute. Okay. Can you see the screen?
Yes, sir.
Can you
Yes,
see?
sir.
Okay. So in this theorem, we proved that the any group of order p raised to n is nilpotent group, or any p group is nilpotent group. The p, एखाद्या ग्रुपच्या ऑर्डर p raised to n असू द्या, तर त्याला आपण काय म्हणतो? p group. Any p group is the nilpotent group. Okay. So one more theorem is there. Look at here. The group G is nilpotent if and only if G has a normal series such that singleton E is equal to n naught, which is the subgroup of n1, subgroup of n2, up to so on, which is subgroup of nm, is equal to G, and ni plus 1 upon ni is contained in Z of G of ni, where I is running from 0 to m minus 1. Okay, this is the last theorem. After that, one more, the group action on a set. Okay, so next point आहे group action on a set. तो पूर्ण डिफरंट हे पॉइंट. ओके, हा तुमचा लास्ट थेरम आहे इकडे इथपर्यंतचा nilpotent वरचा. Okay, what says the theorem? A group G is nilpotent if and only if G has a normal series such that singleton E is equal to n naught less than, sorry, subgroup of n1, which is subgroup of n2, up to so on, which is the subgroup of nm, which is equal to G, and ni plus 1 upon ni, which is contained in Z of G upon ni for I running from 0 to m minus 1. We have to prove that this truth statement, if and only if. Assuming first one is correct, we have to prove this. And in the second part, assuming the second part is correct, we have to prove that G is nilpotent group. Okay. So look at here, the only if part. In this part, we assume that the G be the nilpotent group. Then, by the definition of nilpotent group, there exists a positive integer m such that Zm of G is equal to G, where singleton E is equal to Z naught of G, which is subgroup of Z1 of G, up to so on, which is subgroup of Zm of G, which is equal to G. So this is the definition of nilpotent group, and each Zi of G is subgroup of normal subgroup of G. Why? Because G is nilpotent. By the definition of this one, Zi of G is normal subgroup. Okay, all these are center, first center, second center, third center. Okay, these are the normal subgroup of G. And also we have in the previous lecture, note number third by note, look at here, Zi plus 1 upon Zi plus 1 G, and Zi of G is contained in Z of G upon Zi of G, with I running from 0 to m minus 1. Right, this note. In the previous lecture, we seen. Okay, okay, this one is. Okay, Zn upon Zn minus 1. Take n, replace n of n plus 1. Okay, here n plus 1 is there, then here we get n. Okay, Zn. By using that note, here Zi plus 1 of G upon Zi of G is contained in Z of G upon Zi of G. Okay, where I running from 0 to m minus 1. And each Zi of G, Zi is normal in Zi plus 1. Okay, each Zi of G is normal in Zi plus 1 of G. Therefore, the series is normal series satisfying the required result as the proof. Okay, so there is no need to prove again each Zi is normal in Zi plus 1, because by the definition of nilpotent group, it is always normal in G. Zi of G is always normal in G. So in the first part, we've taken G is the nilpotent group, and we have proved that G has a normal series such that this part is true. N1 is subgroup of N naught is the subgroup of N1 up to Nm, and this one Ni plus 1 upon Ni is contained in Z of G upon Ni. Okay, center of G upon Ni. We proved. Okay, so in the second part, assume G is the group having normal series. Singleton E is equal to N naught, which is less than N1, subgroup of N1, which is the subgroup of N2, up to so on, which is subgroup of Nm, which is equal to G, satisfying this condition, Ni plus 1 upon Ni, which is contained in center of G upon Ni, or I running from 0 to M minus 1. Okay, so put I is equal to 1 here. So what we get? N1 plus N naught is contained in Z of G, center of G upon Ni, which means N1 upon N naught is contained in Z of G upon N naught. Okay, that is N1 is contained in Z of G. Okay, okay, here N1 is contained in Z of G. Can we write like this? दोन्हीकडे फॅक्टर ग्रुपमध्ये N naught आहे. Okay, so we can write N1 is contained in Z of G. Okay, so now let Z of G is equal to Z1 of G. Assuming Z of G is the first center of that group, it implies that N1 is contained in Z1 of G. Put I is equal to 1. Similarly, we get N2 upon N1 is contained in Z of center of G upon N1, which implies that let we have taken X any element from N2. What it means? The N1 of X is belongs to N2 upon N1. So any element from N2 upon N1 which is in the form of N1 of X. Okay, which implies that N1 of X must be belongs to Z of G upon N1. Okay, N2 is the subset of which one? Sorry, N2 upon N1 is the subset of Z of G upon N1. So taking X in the N2 upon N1, we get X belongs to center of G upon N1. Hence, we get N1 of X belongs to Z of G upon N1. So, but हा एलिमेंट ह्याच्या सेंटरमध्ये गेलाय. ह्याच्या सेंटरमध्ये गेलाय म्हणजे काय करतोय? हा N1 ऑफ X हा कॉम्प्युट करतोय. कोणाला? च्या प्रत्येक एलिमेंटला कॉम्प्युट करतोय. कोणाच्या? या फॅक्टर ग्रुपच्या G अपॉन N1 च्या. बट G अपॉन N1 चा प्रत्येक एलिमेंट कोणत्या फॉर्म मध्ये असतो? N1 into Y, where Y belongs to G. Okay, so every element of G upon N1 is in the form of N1Y. Okay, here we have N1 of X belongs to Z of G of N1, which means that the N1 of X must be combined with every element of G upon N1. Hence, we have N1 of X into N1 of Y is equal to N1 of Y into N1 of X. By solving this one, we get N1 of XY, which is equal to N1 of YX. Why? Because HA into HB is equal to HAB by using that definition. Okay. So take the post multiplying by Yx inverse, N1 Yx inverse. What we get? N1 XY. So taking to the right side, Yx bracket inverse, which is equal to N1. But N1 is the identity of that factor group. Okay. Hence, here taking N1 for all Y belongs to G, which means that N1 XY X inverse Y inverse. Yx inverse is nothing but X inverse Y inverse, which is equal to N1 for all Y belongs to G. Hence, that is, if we take an X belongs to N2, here we get X, Y, X inverse Y inverse belongs to N1 for all Y belongs to G. This means that X1, sorry, N1, XY, X inverse Y inverse is equal to N1, which means that X, Y, X inverse Y inverse belongs to N1. Okay, for all Y belongs to G. It implies that X belongs to, but this is the definition of Z2 of G. So X belongs to Z2 of G. Okay, so N2 is the subset of Z2 of G. Okay, here taken X belongs to N2, and here we get X belongs to Z2 of G. Okay, okay, so hence we get here X belongs to Z2 of G, second center of that group. Okay, so this is the definition of Z2 of G. Hence N2 is the subset of Z2 of G. So continuing in this process, this process we get Nm is contained in Zm of G. Okay, it implies that Nm is nothing but G. So G is contained in Zm of G, but Zm of G is the nothing but always contained in G, obviously, because it's the nth center of the group G. Hence it implies that Zm of G is equal to G. Hence G is the nilpotent group. Okay, so assuming this one, we prove G is the nilpotent group. If G is the group having normal series with such like that. Okay, this one we prove that G be the nilpotent group. Okay, any doubt up to here? Any doubt?
No, sir.
Sir.
Okay, if you any have doubt, please they can ask me. बघा हे स्टेटमेंट पुढं. Okay, so in the next lecture we discuss what is the group action on a set. Okay, तो पॉइंट टोटली डिफरंट आहे ह्याच्यापेक्षा. आता हे सब नॉर्मल सिरीज कॉम्पोजिशन सिरीज. ओके, हे पार्ट सगळं संपलेलं आहे. इथून पुढे सगळं ग्रुप ऍक्शन ऑन अ सेट. ग्रुप ऍक्शन काय, जी सेट काय. ओके, सो यू वेट अ मिनिट. अटेंडन्स घेतो. सुरुवातीला थोडा अवघड